Hello, today I will be teaching you the small angle formula, right there. And the small angle formula is used by astronomers for when they're trying to find out the distance between a star and a planet, and you're only given a few options. So, let me show you. Say we have the observer here. That right there is the universal sign for someone looking at a star or planet, because it looks like a little eye. And then we have a star over here, and we have a planet over here. And so let's draw some lines here to show what we're looking at. We're looking at this, and I'm also going to look at this planet. And so let's label these distances. We'll call this distance 1. Call this distance 3. We'll call the distance between the star and the planet distance 2. Okay, so if you've been taught any trigonometry, which I haven't, this is just what I've learned from Charles Balin at the Open Yale course that I've mentioned, and since you guys haven't told me to do something else, I'm just going to continue with the course. You would know that if you learned trig, you would know that sine, the angle at which you're looking, and we're going to call that angle, see if I can do this right, alpha. Can you read that? Okay. Alpha, so let's write a little alpha there, equals d2 over d3. I'm not, please correct me if this is wrong. D2 over, sine alpha equals d2 over d3. Correct me if I'm wrong, because I do not know trigonometry. I'm just sort of repeating what he said. And, however, if this is correct, with very small angles, sine alpha equals alpha. So, hey, no more sines. And this is because, even though these look like complete huge difference in distance, is distance 1, distance 3, they look like they are huge amount of distance change, but they're really not, because we are so far away from the star and the planet that there's not much of a difference. So, D1 is, we're going to just say that equals D3, and that is why sine alpha equals alpha. And so, this gets a lot easier, because D1 equals D3, and that means sine alpha equals alpha. Because now we can write the formula D2 over D1 equals alpha. Remember, alpha is the angle. Now, here's a very simple thing. If D2 and D1 are in the same units, so if units D2 and D1 are equal, then alpha is measured in what's called radians. And if you're measuring in radians, there are 2 pi radians in a circle, or 1 thou. And if you don't know what that is, I'm going to put an annotation right here to Vihart's video on tau, because that is very interesting. You should see that. However, putting tau and pi aside, if you measure D1 in what's called parsecs, and that's represented by PC, and D2 is represented in astronomical units, which we just learned about, which is, if you knew, distance between the sun and the earth. Then alpha, these three things here is the mathematical sign for therefore. Alpha is in arc seconds. And arc seconds, my gosh, they are very, very, very tiny. 1 arc second is a 60th of an arc minute, so 60 arc seconds equals 1 arc minute. Sorry. And then there are 60 arc minutes. Let me move this over, something's getting in the way. Arc minutes in 1 degree. And I did the calculations, and that means there are, ready? 1,296,000 arc seconds in a circle. And so what we've learned today is the small angle formula, which is d2 over d1 equals alpha. Okay? Thank you for listening, watching. I will actually, here's what I think I'm going to do. I'm going to put an annotation right there, and you guys can go look at a video that I made that puts this formula to the test, and you can do some little practice problems with it. Okay, I'll see you there.